Algebra 1, Chapter 0.4, we are going to add and subtract rational numbers today with the multiplying and dividing as well. So before we even, start off with that, let's just compare numbers. Or we'll say rational numbers, because rational numbers can include integers and all of that. So remember, when we're dealing with these, that we do have the four symbols here. We do have the little mouth-type alligator thing going to the left, to the right, to the left with a line, and to the right with a line. Uh-oh. Did I mess up? I messed up. Anybody catch it? Yeah? Yeah, I accidentally wrote the same exact symbol here. So, we have a mouth that opens to the left and to the right with a line underneath it, and those are, starting from the top, greater than goes to the left, less than goes to the right, greater than or equal to, the or equal to part is the line underneath, and then we have less than or equal to. We will start to refer to these inequality symbols as their name, so that way when you see something like x is this right here, that's a 4, that's a bad 4. But if you were to see that, you would read that as x is greater than 4. Okay, so we need to know that if I said, hey guys, x is greater than 4, can you write that inequality? You should be able to do that. The least common denominator. The least common denominator is a really nice way to compare our numbers. Or, instead of calling it the least common denominator, we sometimes go LCD. The LCD, or the least common denominator. What does that mean? What does the least common denominator mean? It says what its name says. When you have a bunch of fractions, you want to know the one denominator that both, or more of them, all go into, right? So it's the denominator. It's a common denominator, or the smallest common multiple of all the denominators. So, speaking of that, if my denominator was a 4 and there was a 16 on the bottom, what's the least common multiple, or the least common denominator of 4 and 16? Yeah, Luke?
4.
4? No. That'd be the common factor. If you were to break 4 and 16 down, actually 2 might be the smallest factor. But common multiple. What number does 4 and 16 both go into? Yeah.
16.
16. 4, 8, 12, 16. If I keep adding or multiplying 4, and 16 goes 16, 32, 48, 64. Where do they cross? At 16. So 16 is the least common multiple. So 16 is one of the denominators that you want to have. So we need to compare some numbers there. Those look a little small on the screen, so hopefully you have them printed off. But they are 2/3 and 5/6. Above it I say, hey, let's get some common denominators. So we got to find the LCD between 2/3 and 5/6. What happens to be the common denominator between 3 and 6? Bill? It's 6. So how can I make that happen? How can I make that happen with the first fraction? What do I do, Charles? Multiply it by 2. You mean just like this? 2 times? Got to do, yes. What I do to the top, I have to do to the bottom, or what I do to the bottom, I have to do to the top. So make sure you are doing that to both the top and the bottom. 2 times 2 is 2 times 3 is? So we end up with 4/6. 4/6, guys, and 2/3 are equivalent fractions. It's the exact same thing. It's just not simplified. And do I need to do anything to 5/6? No. So I'm just going to bring it along for the ride. So now you have two fractions. 4/6, 5/6. Which one's bigger? 5 out of 6 is bigger than 4 out of 6. So the mouth of our alligator, right, should be opening to the right. I want to use that. Or if I was to check my answer and someone said, hey, that's using the blank symbol. It's a less than symbol. So you would put a less than symbol in instead of saying the mouth is opening to the right. Pretty simple, right? Now, is it always going to be nice where one of them is already going to be done for you? No, you're going to have to do both of them at times. So again, find the number that both of them go into. On the other one, it's switching two decimals. So yeah, you don't always just get common denominators, which we can do here because it's 4/3 and 15/9, right? So the common denominator between a 3 and a 9 would be a 9. So I just multiply this first equation by 3/3. Does everybody see that? It would be 3/3. But in this case, what if I didn't want to take the time to do that? I had a calculator sitting next to me. What if I wanted to switch those two decimals? Is that okay? What is 4 divided by 3? Take calculators out. Figure it out. It's 1.3 repeat. Correct. Then take out 15/9. What's 15 divided by 9? 1.6 repeating. Make sure everyone can get that. And I think at this point, what symbol am I going to use? Less than again. So is everybody okay with that? This one is ordering rational numbers on a number line. We already did this, I think, in what? Part 2 or the lesson 2? Where we had the same exact number line. But then it was talking about integers, natural numbers, maybe some fractions were in there. Actually, did we actually do this problem? Does it look really familiar? So we're not actually going to physically finish the whole entire problem, but I gave you some steps here. Take a calculator out and switch them all to decimals. Take your number line, plot them on the number line, then go least to greatest. What was the sticking point on this one when we used our number line to order numbers when we did it last time? Because all of a sudden we had 5 and 5.2 repeat, I think it was, and we had 5.375 and 4.9 and negative 5.6. Right? Those are the 3 numbers we had, or 4 numbers, sorry. Did we leave them in that form? Remember, we don't leave them in decimal form. We put them back to their original forms. So we want to have them in this particular number form for each number, just in the correct order. So, let's just revisit how to take care of a mixed fraction again. How do I convert 5 and 2/9? What do I do? 9 times 5, which is 45, add 2. So it's 47/9. And then you can put it in your calculator a lot easier than trying to figure out how to put the mixed fraction on. Some calculators can do mixed fractions. And if you do this, I do believe you get 5.2 repeat. And then do that with all of them. And you can use the number line if you need to help you, or if you understand which numbers are greater than others, you can put them in the correct order. So that's the first one. The second number was 5 3/8, which ends up being 43 over 8. Oops, 48 over 3, no. 43 over 8, which, 5 point what? You guys have your calculators. 5 point what? 375. 4.9 I think is 4.9. That's not bad. And negative 5 3/5 is negative 28 over 5, which is 5.6. Negative 5.6. So we have 4 numbers there. Now, I say use the number line if you need to. Otherwise, can we look at those numbers and just say which ones are bigger and which one's smaller? What's the smallest? Negative 5.6. Next one. 4.9. Next one. 5.2 repeat. And the final one is... I'm not going to finish it as in you need to convert those back. But they're sitting right below for you. Next is adding and subtracting fractions. You need to have a blank denominator to do this. What is it? Common. You need to have a common denominator, and preferably we like to have a blank denominator. Not equal, but it still has to be equal. It has to have a common. We talked about in the last slide. Least common. So the smallest possible number. You don't need to. You can just have any common denominator to make these things work, but if you use the smallest one possible, you don't have to reduce at the end, more likely. So now it looks like all 3 of these have common denominators. So, looking at the first problem, 3/5 plus 1/5. How can I do this, and how do I show my work? Do we have common denominators? So what does that mean we can do? Just take the tops and add them. So it's 3 plus 1 all over 5. Common denominator. And then 3 plus 1 is 4/5. That is work being shown. You start with your original problem. I did one step. I combined them. And then I simplified. Do the exact same thing for the next one. Common denominator, yay? So, 7 minus 1 over 16. And what's 7 minus 1? 6 over 16. Are we done? Why not? Because you can reduce it. The top and bottom are divisible by what number? What goes into 6 and into 16? You guys told me it was not done yet. It's 2. 6 divided by 2 is? And 16 divided by 2 is 8. So the answer, fully reduced, is 3/8. The last 3 problems do the exact same thing, adding or subtracting, but they don't have common denominators. Now, like I said in the very first problem I think we did, they're not always going to be nice to you and give you at least changing one denominator. Look at 2 and 3. What's the smallest number 2 and 3 both go into? 6. So that means I need to multiply the first equation by 3 over 3. What's 3 divided by 3? 1. So I'm multiplying something by 1. And when I multiply by 1, does it change the problem? No. In the second equation, I multiply by? Over 2. What's 3 times 1? So it's 3 over 3 times 2 is 6. Plus 2 times 2 is 4 over 6. My next step would be 3 plus 4 over 6, yes? And that ends up being 7 over 6. And you ask yourself, is that fully reduced? Yes. Should I convert that to 1 and 1/6? You can, but I would only do it if it asks you to put it into a mixed fraction. Please leave it as an improper fraction. Try the exact same thing, please, with part B on your own. So what do we decide we have to have for a common denominator? It's 24. To make that happen with an 8, you need to multiply it by a 3. So I'm going to put a 3 over 3. A 3 needs to be multiplied by a 8. It just seems like every one of these so far is you just take the denominators and multiply them together, right? Is that always going to be the case? No. Is that an option, though? Yes, it's always an option. But I could have used, instead of 24, could I have used 48? Yes, because 3 and 8 both go into 48. I just would have to reduce at the end. 3 times 3 over 3 times 8. That's what we engineered it to be, minus over 24. And 9 minus 8?
1.
And can I reduce 1 over 24? Negative. So, any questions? How about 2/3 minus 3/4? Common denominator of 12. Oh, that's 2/5. Ah, whoa, sorry. This is the one where you have to do both. What? We have to do both on both of them anyways. Sorry, it's 2/5 minus 3/4. What's the common denominator? 20. Again, just multiplying them through. I think we should all agree it's 4 over 4. And 5 over 5. 4 times 2 is 8. And 4 times 5 is 20 minus 15 over 20. And then I'd write 8 minus 15 over the common denominator, putting them together, right? And what's 8 minus 15? Negative 7 over 20. Can I reduce that? No. And a note on the bottom there, it says when you add and subtract decimals, so if I wanted to, I could have converted every single one of these to decimals and done the same exact rules of integers from yesterday's lesson or from the last lesson. So that means if you're adding 2 positives, the fractions even near, if you add 2 positive fractions, you get a positive fraction. You add 2 negative fractions, you get a negative fraction. Stuff like that, okay? Okay, so your homework from lesson 04 is page P16, 1 through 37 odds. Have a great day.